Welcome to sidza.com. What are aromatic compounds? The term aromatic compound was first used by the Kikule, which actually means odor or the aroma. The compounds which resemble with the benzene have a characteristic smell. That's why this term aromatic compound was used. Aromatic compounds, these are the compounds which are very much stable. They do not undergo the addition reactions, rather they undergo the substitution reactions, right? So you don't just like a normal carbon-carbon double bond in alkenes, which are very reactive. Alkenes are very reactive because of the presence of a pi bond, and they normally undergo the this addition reactions, right? So the double bond breaks and something adds across a double bond. But in case of aromatic compounds, like the typical aromatic compound is benzene, these do not undergo the normal electrophilic addition reactions, right? So they undergo the substitution reactions. This property of the aromatic compounds is what we call as an aromaticity. This characteristic behavior of these type of compounds is called as aromaticity. So now the question is, what are the conditions that a molecule must fulfill so that we call it as a aromatic compound? There are actually three main conditions, right? The number one is that the molecule should be cyclic and a conjugate system, right? It should not be open chain. That means we cannot have a molecule like this an aromatic compound. It should always be cyclic, right? And it should be conjugate. That means there should be the alternate and alternate single and double bonds, right? Like just like we have a benzene. In the benzene we have a double bond, single, double, single, double, single. So we have a complete conjugate system, correct? And the molecule should be flat. It should be planar. You see here in the benzene, every carbon is sp2 hybridized, so hence we can say it's planar. Therefore, a molecule which is a cyclic, a conjugate, planar, and it should also obey the Huckel rule. So what is the Huckel rule? Actually, it should contain the 4n plus 2 pi electrons, right? A molecule that contains 4n plus 2 pi electrons, it obeys the Huckel rule. These are the three main conditions that a molecule must fulfill so that we call it as aromatic. So this 4n plus 2 pi electron, what it is? This n can be anything, it can be 0, 1, 2, 3, 4, 5. So let's suppose if the n is 0 here, if n is 0, so what will be the 4n plus 2 pi electron value? It will be 2 pi, right? So that means if you have a molecule with the 2 pi electrons and is cyclic, planar, conjugate, it will be aromatic. This n can be 1. If n is 1, then this value will be 4 into 1 plus 2, so that is 6. So we can say that 6 pi electron system is an aromatic. 2 pi electron system is an aromatic. 6 pi electron system is an aromatic. If n value is 2 here, so we can say 4 into 2 plus 2, 4 into 2 is 8 plus 2 is 10. So 10 pi electron system can be aromatic. And if it is 3, then you can say 14 pi electron system, and like that. So that means a molecule that obeys the Huckel rule contains either 2 pi electrons, 6 pi electrons, 10 pi electrons, 14 pi electrons, only these values here in terms of number of pi electrons, we can call it as an aromatic. Just like the benzene, it has 3 pi bonds. Actually, 3 pi bond means that there are 6 pi electrons, right, in the ring. There are 6 electrons under the resonance in the conjugate system. So it's an aromatic compound. Now let's see what are the other compounds. Other compounds can be antiaromatic. What are antiaromatics and what are non-aromatic compounds? Antiaromatic is almost similar, with the aromatic. Just the difference is we have here a 4n pi electrons, right? Okay, 4n pi electrons. If you have a compound which is a cyclic, conjugate, and is planar also, but rather than 4n plus 2, just like in the aromatics, rather than 4n plus 2, if it has a 4n pi electron only, then we call it antiaromatic compound. Which means that if you have a 4n pi electron system, it is antiaromatic. N is 1, it's 4. N is 2, then it's 8 pi electron, 12 pi electron. Similarly, you can say 16 pi electron system. These will be antiaromatic compounds. Just like this molecule, if we have a cyclic molecule like this one, it is cyclic, and if you have two double bonds alternately, you can see this is the cyclic. It's a conjugate system. You have a double single bond, right? So this is a completely conjugate system. It's planar also because every carbon is sp2 hybridized, but it's not an aromatic. It is anti-aromatic because it contains what? It contains 4 pi electrons, right? This contains 4 pi electron system. So 4 pi electron system, 8 pi electron system, 12 and 16, these are anti-aromatics, right? The only difference you see here is that rather than 4n pi electrons in the aromatics, we have 4n plus 2 pi electron system, right? If you have this number of pi electron system, and what is the aromatic numbers? We learned that it can be 2 pi electrons system, it can be 6 pi electron system, it can be a 10 pi electron system, and it will be a 14 pi electron system. So that means 2, 6, 8, 2, 6, 10, 14, these are the aromatic numbers, right? And 4, 8, 12, 16, these are anti-aromatic compounds. And in terms of stability, there's a large difference, right? Aromatic compounds are least stable among the three class of compounds, among the aromatic, anti-aromatic, and the non-aromatics, right? So now what are the non-aromatic compounds? Let's look at this class of the compound. Non-aromatic compounds actually are those compounds which do not fulfill either of the first two conditions. Means if the molecule is not a conjugate system, right? It's not a open, it's not a cyclic system. Suppose like this type of a molecule, is it aromatic or anti-aromatic? It's a non-aromatic, right? So if it doesn't fulfill the first two conditions, then you can say it's a non-aromatic compound. So like this one, this is a cyclic, but this is not complete conjugate, right? It's not completely conjugate system. We have a double, single, double, but this part is not conjugate system here. So therefore you can call it as a non-aromatic compound. Again, look at this molecule. This is not cyclic, hence it's not a aromatic compound, right? It's not an anti-aromatic compound. This is non-aromatic compounds. And in terms of stability, we can say aromatics are the most stable compounds, right? Aromatic compounds, and then we have non-aromatic, right? Then we have non-aromatic compounds, and then we have the anti-aromatic compounds in terms of stability. Now let's see which among the following compounds is aromatic. We have to identify these compounds, whether these are aromatic, non-aromatic, or anti-aromatic. Look at the first molecule. It's not a completely conjugate. We have a double, single, double, and this part is not completely conjugate, right? Because you have two single bonds there continue, and this carbon here is sp3 hybridized, right? Isn't it? So we have a double and double, so this is not a conjugate system. Hence we can say this is non-aromatic compound. This is a non-aromatic compound. Next molecule here, we have a double, single, and then we have a nitrogen with the lone pair of electrons. See, this lone pair of electron is also in the conjugation. You have a lone pair, single, double bond, single bond, and then a lone pair. And this electron pair will also undergo the resonance. It will be under the resonance with these pi electrons here. So therefore, the total number of electrons in the resonating ring here will be 6 pi electrons. So therefore, this molecule is cyclic, conjugate, and contains 6 pi electrons. So it is aromatic compound. This one is aromatic compound. Next molecule here, we have a cyclic molecule, and this is a carbon with a positive charge. And this positive charge you can delocalize, so you can have a resonance here, isn't it? You can push this double bond, and you can draw one more canonical structure for this molecule that will look like this one. We have here a double bond now, and a positive charge over here, and a double bond here, and then you can draw another structure also, right? So that means this molecule is conjugate, is a cyclic, right? But it contains 4 pi electrons, right? 4 pi electrons only. In the resonating ring structure here, we see only 4 pi electrons are delocalized. It's a cyclic conjugate, and therefore it's not an aromatic, rather it is anti-aromatic compound. It should be anti-aromatic compound. Next molecule you see here, we have a carbanion. The difference is we have a carbocation, here we have a carbanion, 2 electrons here. So therefore, again you see, just like here the carbocation you can delocalize, carbanion can also be delocalized, because we have a electron pair, single bond, double, single, double, single. So resonance is possible here. So in the resonating ring, how many electrons will be there? It will be 6 pi electrons, right, in the ring. It's a cyclic conjugate and it contains 6 pi electrons, so therefore it will be called as aromatic compound. Next one, you see here we have a carbon which is sp3 hybridized, and it doesn't have a positive or a negative charge, and you have here 2 single bonds there. It's not a conjugate system, so it is just like this one here. So you can say this is non-aromatic compound. This is non-aromatic compound. This molecule over here, you see we have a carbon with a positive charge, so it is just like this particular compound. You see here we have a positive charge and a single double, so resonance is possible. In this case you can delocalize the pi electrons. Let me write down here another structure, another resonating structure like this. You will have a double bond here and a positive charge will be here, correct? And you can draw one more resonating structure for this one. If I push these electrons here to this side and a positive charge will be here, so then you will get a molecule like this. A positive charge will be over here, and then if you shift it here you get this first one back, right? So what you see here in this system is a resonance, right? Resonance is possible. And in this resonating ring, how many electrons you see? Only 2 pi electrons, right? There is a 1 pi bond, so you can say 2 pi electrons are involved in the resonance. So 2 is an aromatic number, correct? 2, 6, 10, 14, these are aromatic numbers. So therefore you can say this molecule is aromatic, right? It's cyclic conjugate and it contains 4n plus 2 pi electrons. Now we have a carbanion here and negative charge. This negative charge, it will also be delocalized by this pi bond. We have a negative charge, single bond and a double bond, so it can also undergo the resonance. So just like here in this case we have a positive charge, you can draw the canonical structures, resonating structures exactly in the same pattern. The only difference is rather than positive charge you will have here a negative charge, and the flow of electrons will be opposite here, correct? You can say if this electron goes down here and this will be over here, right? If this forms a double bond here, then you can draw a resonating structure like this. We can say a double bond will be formed here, and this pi electron, it will shift to this carbon. So you can draw other structure also. Let's say we're gonna push it, this one here and this one will be over here, right? So then you will have a one more structure like this over here, a double bond will be formed here, right? And then if it if it goes over here and this goes here, so you get the first one back. So this is the resonance here in this molecule. And how many electrons are there in the resonance? This is a pi electron system, and one we have electron pair on this carbon, so total number of electrons will be 4 in the resonance, in the delocalization. So 4 is not an aromatic number, it's an antiaromatic. So this is antiaromatic compound, right? This is an antiaromatic compound. Hope you got it. Thanks for watching the video. Bye for now.